Hello everyone. Let's see the points of differentiation between order and molecularity of reaction. While seeing the points of differentiation, few more things will be clarified. For example, what is the meaning of order, molecularity? What about the elementary? What is the meaning of elementary and complex reactions? Okay, what is the slowest or rate determining step of the chemical reaction? So let's proceed. First thing is the what is the order of chemical reaction? Order of chemical reaction is nothing but the sum of power of all the terms, all the numbers, sum of power of all the reacting species in a rate law equation is the order of chemical reaction. For example, A moles of A reacts with the B moles of B, result in the formation of product. Now here in this case, our rate is equal to K into concentration of A raised to X and concentration of B raised to Y. So this is the rate law equation for this reaction, and X and Y, these are the powers of the molar concentration of the reacting species. So sum of power of all the species in the rate law equation is known as the order of reaction. Then next one is molecularity of the reaction. Molecularity of reaction is nothing but the total number of reacting species in a balanced chemical equation is known as the molecularity of the reaction. Here suppose it's a elementary reaction, simple reaction which takes place only in one step. So for the elementary reaction, how many say atoms of the or molecules of capital A are involved? Small a. How many atoms or molecules of this B are involved? Small b. So A plus B, here A plus B is nothing but the molecularity. Okay, molecularity. And here what is order? Order is nothing but the X plus Y. Okay. So this is the first point, definition of both these one. This is the first point of differentiation. Now the second one, that order of reaction is here I'll write, first point is the definition just which is told. Second point is order of reaction is experimental property, and molecularity of the reaction is the theoretical property. Okay, so as to determine the order of reaction, the experiment is to be performed. A and B should react together, and the rate of reaction against the concentration of A. Suppose initially concentration of A is 1, and as the reaction proceeds, concentration of A decreases. So as the concentration of A decreases, what about the rate of reaction? Okay, now as the concentration of B increases or decreases, what about the rate of reaction? So it is to be studied, and then the rate law equation is to be made. So it is a experimentally determined property, it is the theoretical property. Now the next theoretical property, it is okay. Now balanced chemical equation if we see, so then we can state what is the molecularity of it. Then next one is order of reaction. It depends upon experimental condition, and molecularity of the reaction didn't depend upon the experimental condition. Okay, temperature, pressure, concentration, catalyst, these are the factors which affect on the order of reaction. Okay, generally it is stated that so and so reaction, its order is 1, 2, 0, like that something is stated. So optimum range of the condition, most feasible conditions for the occurring of that reaction, it is considered. But let's have an example. Ethyl acetate, CH3COO C2H5. If we bring its hydrolysis, then there will be a formation of CH3COOH plus C2H5OH. If this reaction is carried out in acidic medium, okay, so the order of reaction is 1. And same reaction, instead of acidic medium, if it is carried out in a basic medium, OH minus, so the order of reaction is the 2. Okay, now so the experimental condition is get changed, order of reaction is get changed. So order of reaction, it is not always that always it is changed and order will get changed. No, so better to say order of reaction may change based on the change in the experimental condition, but the molecularity of the reaction will not changes. Okay, it will remain identical as it is. Then next thing is that Fourth point of differentiation is their value. Order of reaction, its value is either it may be integer, it may be fractional, it may be zero, okay, but the molecularity of the reaction is always integer. It should not be fractional, it should not be zero, okay. So next one is, means what order of reaction we are seeing, it may be 0, 1, 2, 3, 4, it may be 0.5, 3 by 2, like that order of reaction value can be, but molecularity should be a, it must be a integer, either 1, 2, 3, 4, okay. Then order of reaction, next point is, order of reaction we can't determine by seeing only the chemical equation. If we have a balanced chemical equation, it is true that for the elementary reaction, order of reaction is equal to the stoichiometric coefficients for the elementary reaction, for the simple reactions which are get completed in a one step. But for the molecularity, the balanced chemical equation, by seeing the balanced chemical equation we can state the molecularity of the reaction. Then order of reaction, it gives the relationship between rate of reaction and concentration of reactant raised to a certain power. Okay, molecularity of the reaction gives us idea about the total number of the molecules or total number of the reacting species involved in a balanced chemical equation. Rate and molar concentration, how they are related, we are getting information by the order of reaction, and total number of molecules we are getting by the molecularity of the reaction. Order of reaction is the property of elementary reactions as well as the complex reactions. Means those reactions which are occurring in one step are the elementary reaction. Complex reactions are the reactions which occurs in a multiple steps. Okay, and here it is a property of the molecularity of the reaction is the property of elementary reactions only. The last point, say for example twice of NH3 decomposes to form N2 plus thrice of H2. Okay, 1130 Kelvin temperature, platinum as a catalyst. So for this reaction it's a zero order reaction because rate of reaction is independent upon concentration of ammonia, but the molecularity of this reaction is, molecularity of the reaction is 2 because 2 molecules of the ammonia we are seeing in the balanced chemical equation. So molecularity of this reaction is 2, but practically it is found that rate of this reaction is independent upon concentration of ammonia. That's why order is 0. Okay, so these are the major points of differentiation between the order and molecularity. Okay, by all of you.